Yes, of course. Well, literally speaking, paleohistology is the study of tissues, of, of animals and plants, of life, or at least evidence of past life from fossils. So, but of course, for most of the people in the program of the meeting that we're attending on paleohistology, these are people who are interested in animal life. And so they're looking at the tissues, and the only tissues of ancient animal life that we have are bones and teeth. So it's a way of looking into the past. I think can also define themselves as time travelers, traveling back through time, looking at the bones and teeth from the point of view of history, and understanding how to reconstruct the history and bring it to the present. That's a good question, because what most people see are just teeth and bones. And quite honestly, many people have the idea, at least until they break their bone or they have a problem with their teeth, that they're dead objects, even in the living body, that they have no other substance than the fact that they are hard and they can hold you up and they can help you to chew your food. But anyone who has broken a tooth or who has a cavity in their mouth will know that there are many nerves and that there is a blood supply and that these are living tissues. And so the challenge for paleohistologists is to acquire these tissues from fossil animals, to investigate them using a variety of technologies, usually of which is a microscope of some kind to look very closely at the tooth or the bone, to look at the microscopic anatomy, the morphology. Now, to the morphologist, it's a structure, it's an object, and within that object, the bone or the tooth, there is finer structure, and this finer structure has some meaning to a paleohistologist. But the important thing to recognize about the science and art of paleohistology, that the interpretations of this structure is not just anatomy, but that, in fact, the structure represents a process. It represents developmental activity. It represents maintenance of the organism. It represents something active. So the morphology, which is a static anatomy, must be interpreted in terms of the processes by which these bones and teeth were formed, and that helps to explain something a little bit more dynamic about the past. Well, we're learning more about what it means to be human, in the sense that to understand ourselves, it's sometimes quite useful to look at the behavior of your ancestor, to know why you have the adaptations you do, why you have the structure you have, why you have the ideas in your head about the sorts of things that you should be doing as a human. These are all interesting questions, and you wonder, well, how can such questions be addressed using paleohistology, which is a real challenge. But I'll give you, for instance, one example. By looking at the developmental processes responsible for the growing bones and teeth of early humans, we are learning that there are aspects about human physiology that have never before been understood. One would think that there are plenty of humans around today, human biologists working on living humans, that they would understand their physiology, how they grow, how they develop. But in fact, there are a number of things that have been missed. And one of the reasons they've been missed is because I would say that in palaeohistology you have to be exceptionally creative in order to get from the bones and teeth some little bit of information that tells you about the life of these early people. And that creativity sometimes leads to discoveries in morphology and in the examination of process, how bones and teeth were formed, that teaches us something about human biology we didn't know even from modern humans. And I think one of the most significant examples of that today is that we have discovered that there are biological rhythms other than the daily biological rhythms, and that these rhythms are long period rhythms. They last for more than one day. And these are true physiological, metabolic rhythms that we have identified from the bones and teeth of early humans. And now, looking at this prospectively at modern humans today, discovering that they're there and that they explain something about modern humans. And to give you one example, this long period rhythm that we have discovered from the fossil record is a rhythm that appears to be helping to generate the large body size variation that exists in modern humans. Modern humans are the only mammal known other than the domestic dog that has such a great range of body sizes. How does a species manifest all that variation? There has not really been an answer to that question. And we're discovering that these long period rhythms are about generating that kind of variation. So for someone who is quite small, a petite woman, say, her long period rhythm may be 9 or 10 days, whereas for a large, robust man, it might be 6 or 7 days. And this rhythm is actually generating how they develop and how they maintain themselves. And this is a fundamental aspect of human biology, which is only now coming to be understood from having pursued palaeohistology of early humans.